here, I just want to point out where we're at. We're going to talk about graphing today, and Monday I will be handing out your first take-home quiz that will be due Wednesday of next week. And also Monday, Project 1 is due. Okay, Project 1 is due Monday. However, I want to point out here, if you go to the syllabus, there are different grading options in terms of what assessments are weighted how, right? And you'll notice that the test heavy option does not count projects. Okay, so I would encourage you to do everything up until the first test, and then if you go, oh, it looks like I'm going to be, the tests in here are reasonable, I'm a good test taker, like then you can kind of back off a little bit if you want to put all your eggs in the test heavy basket. But I just keep in mind, this is sort of the first place where you have to make a decision, like, am I going to hand this project in or not? I would encourage you to do it, especially this first one, because it's a good intro to Geogebra, which is a useful tool all semester. So just wanted to point that out. So that project is due Monday. All right, so today we're at class 3. Why don't you take 5 minutes or so to work through the preview exercises, discuss with your classmates, and then we'll get into the demo portion. Okay, so today we're talking all about graphing, right? So we're going to first talk about finding x and y intercepts of a graph. So the x-intercepts of a graph are the places where the graph crosses or intercepts the x-axis. And similarly, the y-intercepts are the place where the graph crosses or intercepts the y-axis. So if we look at our preview exercise, y equals 4 minus x squared, and you all graphed it, what are the coordinates for the x-intercepts of that graph? Where does it cross the x-axis? Great. So when you're giving x and y intercepts, you should give both coordinates. So we've got 2, 0, and -2, 0. Those are our x-intercepts, where it crosses the axis. And what about the y-intercept? Where does this thing touch the y-axis? 0, 4. Great. Good. So to find these things algebraically, without plotting the entire graph and searching for where it crosses, we can find these algebraically by being a little bit strategic. Okay, so if you're looking for an x-intercept, I'm going to draw a little set of axes here. No matter what point I pick on the x-axis, this one, or this one, or this one, or this one, any point on the x-axis has coordinates something, comma, what? 0. Any point on the axis is something, comma, 0, right? Which coordinate is 0? Y. So if you're looking for x-intercepts, you make the y 0 in your equation. So I have y equals 4 minus x squared. I'm looking for the x-intercepts, that's a place on the x-axis, so I make the y 0. So I do 0 equals 4 minus x squared, and I solve for x. Okay, so I'll just add x squared to both sides, square root of both sides, and I get x equals positive or -2, right? The two numbers that you can square to get 4. So that's how you can find x-intercepts algebraically. We'll do a similar picture for y-intercepts. So for any point on the y-axis, here or here or here or here, all of those points have coordinates 0, comma something, right? You don't go left or right, you just go up and down. So every point on the y-axis has an x coordinate of 0. So in your equation, you make the x 0 because it's got an x coordinate of 0. So you do y equals 4 minus, make the x a 0, y equals 4 minus 0 squared. So y equals 4. And there's my y-intercept. Does that make sense? All right. Okay, so we're going to do a little intro to using graphing utilities that are going to be used in this course. I'll do a little bit with the graphing calculators. I handed out some so that you can follow along, and you'll use the graphing calculators in your class activities in a little bit. And then I'm going to do a little bit about Geogebra, which you'll use more of on Project 1. Okay, so for the graphing calculator, I want to graph the equation y equals 4 minus x squared using the calculator. You already all did it by hand, so pull up my calculator here. There are several different versions of the TI 83, 84. I have an 83 plus up here. So some things may occasionally look a little bit different, but they basically work the same. All right, so to graph the equation, step 1 is press the y equals button. It's in the upper left. If there's anything in there, just press clear. Yes. I don't have any more batteries. It exploded? Oh, yeah. Let me just put that away, and I'll ask you to look on with somebody. Oh, great. Thanks. Okay, so now we're in this screen. If there's anything there, you want to press clear. And then we want to enter the equation next to y1. So y1 equals 4 minus, the x button is in the upper left quadrant. It says xt theta n. That's what you use for x. Second column, third one down. And then to square it, for exponents, you use this little caret, right? This little hat thing. And that means raised to the second power. So you do a little caret and then a 2. All right, and then you press the graph button, upper right. So you may or may not get a picture that looks like mine, right? Because what we have to do is decide what window to look at. The coordinate plane is infinitely large, right? X and Y extends in both directions. So it's wide and tall, infinitely so. So we have to decide what, we only have this little teeny tiny screen. We have to decide what portion of that infinitely large thing do we want to look at. So we want to choose a viewing window. It's an important consideration. So you go to window, it's right next to y equals. All right, so I want to choose the smallest x value and the largest x value. From where to where along x and from where to where along y do I want to look? Do I want to zoom in on? So I'm just going to go -10 to 10. Skip this x scale and y scale. I just always leave those at 1. The only thing I ever change is x min, x max, y min, y max. So I'll go -10 to 10 for y also, and press graph. Now everybody should have the upside down parabola that you got when you did it by hand. Anybody not getting that in their calculator? Great. You get something extra? Go back into y equals. Oh yeah, go down to y2 and press clear. Here, you know what you can do is you can darken it by pressing second and then this arrow. It is the battery, but as it, yeah. There you go. All right, so that's how we graph it. That's how we change the window. So just a shortcut for getting the standard window that we just came up with. And this is notation for windows. If you see things in square brackets like this, you always read it as x min, x max, x scale by y min, y max, y scale. Okay. So something in your homework might tell you to graph with a window like this. So you have to know what those numbers mean. Okay. Yeah, it's just how far apart are the little tick marks on the axes. So a shortcut for getting that is to press zoom 6. Z standard gets you -10 to 10, -10 to 10 really fast. Okay. All right, so now for a little GeoGebra demonstration. You can just put the calculators aside for a moment. We'll use them again in a few minutes. So Geogebra is a free downloadable software that we'll use frequently in and out of class. I will do demonstrations with it in class, and I might ask you to do some things with it outside of class, particularly on projects. So let's get this open. So I've got a Geogebra icon right here. If you don't have it downloaded yet, it's just geogebra.org, and you download the software. It's free. All right, so first thing I want to do is graph the equation y equals 4 minus x squared. So to do that, I just type that exactly into the input bar at the bottom of the screen. So I go back to GeoGebra. Down here is the input bar down at the bottom. And I type in y equals 4 minus x. And again, you use the caret, which is shift the number 6, gets you the caret, and squared. And then you just press enter, and it graphs it. So there's lots of cool things you can do, but the main thing you need to know how to do is change the window, just like with the graphing calculator. And you use this little move button to do that. So you click that, and then you can click anywhere. Like I can click right here and drag the whole thing over, so to kind of center it. And if I want to change the scale, you take your cursor and hover it over an axis until it becomes that little double arrow. And then you can click and hold and drag down or up to change the scale on an axis. So you could do it on the x-axis too, scale out or in, however you need. The other thing that you can do pretty easily is add a grid so that you can see the grid paper in the background. And then the first project will guide you through lots of other things that GeoGebra can do. So right now, the name of this graph, they named it C. If I don't want it to be named C, I could double click and do object properties, and I could rename it, right? Or I could say, instead of showing its name, I could show its value, which would be the equation, and then it labels it with y equals x squared plus 4. So there's tons and tons of things you should play around with in here. It's really user-friendly and great. So the first project will guide you through a lot of cool things that it can do. And it will be a great resource as you're working on homework and things too. If you don't have a graphing calculator, GeoGebra will be really handy. So those are the basics. Again, you'll learn lots more through Project 1. And that's it. You can start your activity. I gave out graphing calculators. Use them as needed.